Hello guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in the previous tutorials we had a look at DHCP spoofing, poisoning, DNS poisoning and ARP poisoning. But there is one more term before you could get rid of the MITM attacks, and that is ICMP redirection. And this is quite different from all the other attacks. The reason being that, okay, I'll tell you later on that. And by the end of this tutorial, you will be having sufficient knowledge for going ahead and doing all the MITM attacks out there and how to prevent yourself from them as well, unless you don't fall prey to social engineering. And yes, and the last thing that I would be teaching you by the end of this tutorial would be how you could go ahead, and I would actually practically like to show you a few examples of how we could go ahead and use Ethernet or EtherCap to go ahead and actually capture some packets and get data out of them by stripping off SSL security or sniffing and spoofing and going ahead and gathering information over the MITM network and becoming a man in the middle. And yeah, that's right. So first let's start with the ICMP redirection. So an ICMP redirection is an error message sent by a router to the sender of the IP packets. So redirects are used when a router believes a packet is being routed, you can say as suboptimally, and it would like to inform the sending host that it should forward subsequent packets to the same destination through a different gateway, because that gateway is not able to perform in a good or sufficient data analysis, due to which it is not able to send the proper packets in the same direction. That's why it will ask you to go ahead and send it through a different gateway. So in theory, a host with multiple gateways could have one default route and learn more about optimal specific routes over time by the way of ICMP redirect. So let's consider the following diagram. This diagram, simple. So in this figure, you can see that host A over here, it wishes to send a packet to the host B. The routing table on the host A consists of a default route through router R1, that is, which is one over here. And when R1 receives a packet destined for host B, it looks at its routing table and notices that it has a route not default to R2, that's router 2 for packets, but that is destined for host B. So therefore, it forwards the datagram to R2, which in turn passes it along to the host B. Router 1 also notices that the outgoing interface and network for the packets was the same as the interface it arrived on. Since it is configured to send ICMP redirect, it sends an error message to the host A informing it that all packets destined for host B should be forwarded to R2 and not to R1, or else it will not be able to go ahead and communicate with the actual Ethernet part. So it makes sense for router 1 to send a redirect because host A could have just as easily sent packets through R2 to start with. Sending packets through R2 directly would decrease the number of routing hops for host A and increase the performance on R1's link. Obviously, redirects would not be involved if host A contained a static route to R2 for packets to host B, or if R1 could forward packets to host B through a better path such as directly connected interface. So if this was directly connected, or if it would somehow go ahead and pass all the data to router 2, then it would be sufficient. But since it cannot, it will straight away go ahead and give an error message to A that it is not able to go ahead and send the packets to actual connection B, because for the router A, it does not even belong over there. Means it will not even recognize whether there is a host B. It will only think that there is host A, the reason being that it is only connected to A, that's why. So it will go ahead and send an error message, but the computer host A will not stop looking for the correct path. It will go ahead and try to send it to the router 2, that's R2 over here, and then it will be able to connect to B. So there are different ways of connecting. However, there are different rules for the route, and there are several governing that govern the rules of ICMP redirects and their acceptance into a host routing table. Before an ICMP redirect is generated, there are following restrictions that are typically adhered to on most of the today's routers. The first thing is that the outgoing and the incoming interface of the packet must be the same. If they are not the same, that means somehow they were disauthenticated in between, and either part A or either the host A or host B will not accept it back again, and it will just go ahead and dissolve in the whole network when the data network transfer starts again. The IP source address in the packet, that is the second one. The IP source address in the packet is on the same logical IP network as the next hop IP address is. To be more specific, if it tries to go, if there is no connection between them and the IP address source is different, because for example, let's say it's 192.168.1.1 and over here it's 192, or you can say it's 172.1.1.1, something like that, anything random, but it is different from the source of over here A, then it will again not be able to collect. The reason being that there won't be any connection within the LAN network if both the IP addresses have a total different configuration. The third thing is that the route used for the outgoing packet must not be an ICMP redirect or a default route. To clarify it a bit more, let's say A has transferred let's say 8 MB packet to 8 KB packet to router A. So this is the default way, or the gateway for the host A. This is the default router, that is the gateway. So but at the same point, this is also the ICMP redirect path for host A, because when it transferred to go ahead and when it tried to go ahead and transfer some data to host B, it redirected it back to A, stating that there was no such connection as B. So to make sure that you have a connection with host B, there should not one should not be either the default or one should not be either the redirect gateway, because if both are the same, then it again won't be able to connect. But if one is the default gateway and it is ICMP redirect, then this should be the default route, else it won't be able to connect. Or if this is the ICMP redirect, then this should be the default gateway, else it won't be able to reconnect. The fourth part would be the packet data does not contain an IP source route option. So that means that if this has any random IP address, then the packet that is being sent should not have a gateway or let's say an IP address configured by a different gateway. The reason being that if they are on the same LAN and they have different gateways and different IP addresses, again they won't be able to reconnect. They should have either the same gateway or a same type of IP addresses in the same similar manner, or else it won't be able to reconnect. And the fifth and the foremost important part would be the gateway must be configured to send redirects, so that if router 1 is not configured to go ahead and send any redirects, then A will keep on trying to go ahead and connect to B. It will not even redirect any traffic back to A, so it will still keep thinking, or it will still keep looping the same thing again and again, and it won't even be able to sense that it was not able to connect to B, because the router 1 will never tell A that there is no connection B. It will just go ahead and consume all the data bandwidth in between. It will get destroyed, and it will just be like a black hole. You're just trying to send something, but you're not receiving anything back, and you won't even know what is happening over there. That's how it works. But if this is configured to go ahead and redirect it back to A or to router 2, then it will straight away go ahead and redirect to either of those, and then it will be able to send the packets. So RFC112 of 2, that is the, you can say a section something like that, it states that the host should not send ICMP redirect. If A is able to redirect an ICMP, let's say for example, if A has sent some packets to 1, it should not be able to redirect the same packet to the router 2, else it will not be able to send, the router 2 will not be able to send it to host B, because router 1 has already went ahead and denied that. That's the reason. So whenever it receives a redirect from the router 1, the A should go ahead and particularly deny or destroy the data and resend a new packet with the same data to the router 2. Else again it won't be able to reconnect after that. So there are specific kind of particular routing table that one needs to know properly before they go ahead and actually connect to the ICMP redirection. And multiple other, you can say, as checks that are typically performed at the host, and they're not all mentioned in the RFC 112. And just if you're wondering what RFC 112 is, I'll just go ahead and show that to you before I close this tutorial. So I can just type, I'll just go ahead and connect to my website. Yeah, perfect. Okay, after surpassing my gateway, I'll just go to RFC 112. As you can see, RFC 1122, that's requirement for internet host communication layers. They have set up different types of walkthrough through which we have to go ahead and configure each and every protocol. If they don't don't satisfy that, then they won't be able to reconnect, or they won't even be able to go ahead and actually surpass anything along. So that's it for this tutorial, and in the next tutorial I'll be teaching you the different ways of connecting and what are the different checks that must be performed, but they're not listed in RFC 1122 before adding a redirect route to the routing table. So that's it for this tutorial, guys.